In this video, we're going to talk about how to deal with situations or identify situations where we have a line in the circle and they meet at two distinct points. All right. So I'm going to use a couple of examples to explain, right? And to explain the concepts. But essentially, you have, in this example, we have a circle, right? So a circle has the equation x minus 2 all squared plus y squared is equal to 2, right? And then you have a line which has the equation y is equal to x minus 2, and that's it, right? So when it comes to finding the point of intersection, right? If we're looking at points of intersection and we're trying to find the point of intersection, we've discussed in previous videos that that means you have to solve the two equations simultaneously, because simultaneous equations means you have two functions. Both of those functions, in order for us to join them, have to share the same x and the same y. So if we're saying that they're intersecting, that means, yes, they have the exact same x and the same y because they are meeting, right? So they're coming to a point where their x's are the same and their y's are the same. So we can solve for these and find those points using simultaneous equations. So what we can do is we can take equation number 1 and then we substitute that into that expression. The easiest way for us in this case to do this is to take this y expression and then put it into that equation. So your first equation becomes x minus 2 squared plus, now instead of having y, right, because remember we're saying we're substituting x minus 2 into there. So you now substitute the x minus 2 in place of y. Remember your whole y was being squared. So that means that x minus 2 as a whole needs to be squared as well now. Okay, and then that's going to be equal to 2. All right, so now let's take this expression. This is going to be, if I expand this, now we're going to do the expansion a little bit quickly, right? But if you need to do FOIL slowly on the side, you can go ahead and do that. But what we do when we're squaring a bracket is we say first expression within the bracket, your first term, which is x, is going to be squared. Then we say x times negative 2, which gives us negative 2x, but you multiply that by 2, so that gives you negative 4x. Negative 2 squared gives you positive 4. So that's your first one. And then your second bracket is actually exactly the same. So we're going to say x squared minus 4x plus 4. That's equal to 2. Right? And then we group our like terms. So which means we're going to take all our x squared terms, which are these ones. Right? So you have x squared plus x squared, which gives you 2x squared. Next, we're going to take our x terms. So you've got this expression, you've got that expression. All right? So that's going to be negative 4x minus 4x. That gives you negative 8x. All right? And then next up, we're going to take all our constants. So for constants, we're going to take the positive 4 plus 4. The 2, I'm going to jump a step here. Hopefully it's not too confusing. When the 2 comes to the left-hand side, it becomes negative 2. Right? So you have plus 4, which gives you positive 8, minus 2, which gives you positive 6. 4 plus 4, 8 minus 2, that gives you 6. So that's going to be positive 6 for us over here. And then we have a 0 on that side. The reason why we do this is so that we can have one expression where we've grouped our like terms and then we have nothing on the other side, because that's how we deal with quadratics, right? And then can we simplify this any further? Yes, we can, because we have each of these coefficients is a multiple of 2. So we can divide each of these expressions by 2. So it cancels over here, but over here it becomes 2 into that, it goes in 4 times. Divide by 2, it goes in 3 times. So now your expression becomes x squared minus 4x plus 3. That gives you 0. All right, cool. Now let's take a beat here, right? So thing is, when you are solving simultaneous equations between a circle and a straight line, you're always going to come to a quadratic. It might be missing its terms. You know, sometimes it might just be x squared plus 3, whatever. But you're always going to come up with a quadratic. Again, even if let's just say, for example, if we had taken this as y plus 2 is equal to x, and then we take this x expression and we substitute it here so that our quadratic ends up with y's. The exact same concept stays the same, right? We still end up with a quadratic that's in terms of y. So we're going to end up with a quadratic expression, right? And for quadratic expressions, Ideally, you're going to get two solutions, right? But what we're going to do is we're going to say, okay, for quadratic solution, we need to identify what our A is, our B is, and our C is. Our A is the coefficient of x squared, which is 1, or at least positive 1. The B is the coefficient of x, which is negative 4. The C is the coefficient of is the constant, which is positive 3. So now once we have those, we then say, okay, in order for us to solve for x, we're going to use the quadratic formula. Square root of b squared minus 4ac over 2a. So now we can substitute our values, right? So that's going to be negative b, right? So that's negative 4, right? Which just gives you positive 4. Or at least just so that it's not confusing, let me just write that negative 4. Plus or minus the square root of b squared is negative 4 squared minus 4 times your a value, which is 1, times your c value, which is positive 3, divided by 2 times a, which is 2 times 1. You just write that as 2. Just to simplify this, negative 4 becomes positive 4. Plus or minus, we can now throw this, so we have the square root of, we can throw this whole thing into our calculators, right? So you might be hearing me doing that in the background, but negative 4 squared is 16 minus 4 times 3. That gives us positive 4, right? Divided by 2. Now, I know your calculators, sometimes you can just throw those into your calculator, into them, and then they can solve them. In fact, we can even do that before you start to apply here, but it's important to understand why we're doing this, right? The thing is, the idea behind a quadratic formula is we have two solutions. You can either plug in as a positive, so it can either be 4 plus the square root of 4 divided by 2, which gives you a solution. What solution does that give you? That gives you 4 plus 2, that gives you 6, divided by that gives you 3, right? That's your first solution. Or you can plug in, or that sign can be negative, so it can be 4 minus the square root of 4, divided by 2. So 4 minus 2, that gives you 2, divided by that gives you 1. Right? So your answer can be either 3 or 1, but the only reason why we were able to get two distinct solutions is because when we added this and subtracted this, 4 plus 2 gave us 6. 4 minus 2 gave us 2, right? But if this was 0, it wouldn't have been able to give us two distinct answers, because 4 plus 0 would have given us 0. 4 minus 0 would have given us 0. So the only reason why it's giving us two answers is because now we're going to use a term from the last video that we used. It's called a determinant. The only reason why we're able to get two distinct solutions is because this value that's inside our bracket, right, our b squared minus 4ac, which is called the determinant, was greater than 0. Right, so your determinant, which, this is the sign for determinant. Your determinant is greater than 0, so which means you're able to get two distinct points, right? Your 3 and your 1, and then we can plug into this to get the y terms for those x values. But the whole point of this video is just to emphasize, in order for you to get two distinct solutions, you need your determinant, that b squared minus 4ac, this expression that falls into your square root. You need this to be positive, so that when you add and subtract, it gives you two distinct answers, which are 2 points of intersection. Don't forget, the whole reason why we're doing this is we're saying, okay, there's an x value that applies to both your circle and your line. What is the x value? That is that x value where they meet. It's this x value and it's that x value. We're looking for points of intersection. So if we have two answers, it tells us that they intersect at two different points. Okay, so that is, so essentially, if you want to summarize this video, in order for you to get 2, right, so when your determinant is greater than 0, this means you have 2 points of intersection. But remember, this is the determinant once you've substituted, after substituting. Line equation into circle equation. right? So if you want to take a summary out of this video, essentially that is what that summary would read. So I'm going to end this here, right? We'll look at some more complex examples I've introduced solid examples for the other two cases for the tangent, which is going to be the next video. So in the next video, we're going to look at an example where we have a circle, we have a line, and those two are tangents to one another. And then in the next one, it's going to be no solutions. And then from there, we'll look at a couple of complex examples that need us to apply ourselves and to apply what we've talked about here. But for now, we'll stop this here. Hopefully this made sense, and I'll see you in the next video.